Okay, so this is the second video on OpenGL in Linux using C. And of course, OpenGL is a C library. A lot of people use C++, but for this particular tutorial is about C. Anyway, yeah, I mean, this stuff will also work in C++, basically. Okay, so last video we made a window with background color, and now we want to make a triangle. That will be the next step. So again, I have this kind of basic project over here. I'm going to be copying and pasting stuff in, but in the last video I forgot to just make a commit. So makes a window with color. So I'm going to commit it. Another little tiny thing that I want to do is, instead of return 2, we return 0, just to be good little boys and girls. Alright, so the triangle. So for the triangle we are going to need a vertex shader and a fragment shader. That's just how OpenGL works. And later we're going to put this in different files and all that, but for right now we're just going to do like this. So let's see here. So this is sorry that this is a bit small. Yeah, we're gonna need a VAO. That's a vertex array object. So there's a lot of stuff that we are going to need. I also in here use the library CGLM. I believe GLM is a math library that uses C++. And CGLM is an open source project to basically provide the same stuff in C. So I'm not using those yet, I don't think, but just thought I'd explain that. Vertex, I think. Okay, this is a weird project. Anyway, let's copy in vertex shader source and fragment shader source to start. So I'm just going to copy that, paste it in. Alright, so right now this is very confusing to look at. I get that. When it's in a different file, it will be easier to read. But basically we have these quote marks, and yeah, these are lines of the code. This is basically, these are both in a language called GLSL, which is something like OpenGL, GLSL, shader language. Okay, it's shader language. OpenGL shader language. It's, yeah, GLSL. So first we say a version. 3.30 is kind of it's going to be very compatible with all kinds of things. Sometimes you do need that there. Then we have a layout. So this is all getting kind of complicated. Let's just get stuff working, and then you know, I'm not going to explain everything in perfect detail right from the beginning. I'd rather just kind of show how things work first. And although I'm explaining stuff right now, you don't need to know everything at first. But this is basically passing. So the vertex shader is going to deal with the vertices. And a fragment shader, basically, a fragment shader receives its like XY coordinates. You can think of it that way. And then it outputs generally a color. I think it only outputs a color. Okay, so here we have GL position, and then we have this frag color. Yeah, it looks confusing right now. There's just no way around that. But just know that the vertex shader obviously figures out where the vertices are, and a fragment shader, basically it outputs a color, and it basically takes some kind of XY coordinate and then converts that into some kind of color. So we're going to start out real basic with triangles and stuff that demonstrate how well that works. Okay, so we have that. So we need to build a shader program. These, it's another programming language, right? It's GLSL, and that is used to actually compile a shader, and a shader is actually a program. So it's a program that is meant for your GPU. Okay, so we have this int shader program stuff. All right, I need to probably not use this one. Well, okay, let me. I guess it doesn't really matter. Vertex array blah blah. What the hell is going on? Oh, it must be down here. I've had other projects where I've used this stuff, and there were different header files and stuff. But okay, so I've put this all into some kind of silly sounding function. Vertex array blah blah. So we'll copy that in. Let's do this. Let's add in the functions that I have, and then we'll see if we can get it to compile with no errors. At some point I will try to explain stuff. Okay, so this is going to come after everything. Now, personally, I added at the end because it's not something that I ever really look at again once you get stuff set. I mean, yeah, maybe you do. It depends on what you're doing. Build shaders, okay. We're going to need that. So we have a build shaders function. We have a, I admit this is not the best name thing, vertex array blah blah. Here I kind of put the window generation stuff into a separate file, but what I'm going to do here is just uncomment this stuff from the previous, previous version. I'll be checking later for what all this stuff does, but this is basically saying that it's version 3.3. I wrote this code so long ago. I'm sorry, I don't know what's necessary and what's not necessary, but we'll take one thing at a time here. So so what's in the while loop here? Sorry if it's too small, you can't see it, but this is kind of the game loop, if you will. So I actually do like the way this is set up because it's pretty straightforward. Let me make that a little bigger for you. We have generate window stuff. That's already here. We're going to make a program. So this build shader function receives the shader program, which is just an integer. Actually, these things just, I guess, are kept track of just using by GLFW, just using integers to identify them. So we'll copy that in. After all the Windows stuff, we have our while loop. So let's do this. Like I said, I don't want to deal with this stuff yet. I want to see if it will compile. We're going to need our function declarations. I'm going to get rid of the, should I get rid of the generate window one? I'll just get rid of it for now. There's also a process input function. I'm going to leave out for now. We don't need any input. So we have a build shaders function, a vertex array, blah blah. I definitely need to rename that later. Sorry for the silly name. And let's see if this will compile without giving errors and still show us the color that we used before. Yeah, it's working. So I'll go back into main. Now I'm going to comment this part back in. This line should definitely not be a problem. And let's see what happens with the others. Should be okay. This is, yeah, should be okay. So we have a vertex array, a VAO. So VAO is vertex array object. There are different ways of handing vertices to your GPU. Vertex array object is kind of, or vertex array is kind of the most basic one. So we bind it. There are all kinds of functions in OpenGL where you bind and unbind things. So I guess OpenGL is meant to be, there are a few sort of metaphors that they use. They use a client-server metaphor, and also they talk about it being a state machine. So yeah, think of it as a, I don't really know the technical definitions of those things, but it is what it sounds like. A state machine is a fancy term, but you basically, if you want to use the vertex array object, you need to bind it. And so sometimes you might switch it up and use a different vertex array object, and then you would want to unbind that one and then bind a different one. For example, what we're going to do here is first a triangle. I think a triangle. This might be for a quad. Yeah, this is actually for a quad. So we have two triangles here. And so we'll start, it's fine, we'll start with that. Quads are more useful. And so if you were doing a cube, you would probably definitely want to use different vertices. So that's an example where you would probably use a different VAO. Of course, you could use, so let's say you're making a game and you want to have cubes involved, but you also want a kind of a HUD, you want basic like 2D graphics to happen too. You could just use some of the first few vertices from your cube object, but that's a choice that everyone can make themselves. To start out though, we're going to keep things simpler. Okay, so this EBO, the OpenGL gets these vertices and this, then we have to tell it sort of what direction in which to sort of which vertices are which, okay? Because it doesn't know by default how to draw things. The vertex array object has these 4 vertices, right? But how is it going to, it can only draw triangles. How is it going to know how to draw the triangle from 4 vertices? That's where we tell it. We give it these indices, and EBO is element buffer object, I think. So let's make this full screen. So yeah, for now, don't freak out if you don't understand everything very well here. But these buffers are just space in memory. So we make with OpenGL, we generate these buffers, VBO, EBO. And the VBO is for the vertices, vertex buffer object. EBO, I believe it's elements. Yeah, because it's element array buffer. So I guess elements buffer object. So yeah, again, it looks super complicated, but don't freak out. So in order to do anything with the vertex array object, we bind it. We bind the vertex buffer object. We buffer data, which takes the vertices that we put up here, and so it this attaches it to this buffer object, essentially. Then we need to do something similar for the EBO, and this time it takes the indices that we have up here. And then we have the GL vertex attrib pointer. What this does is it tells, I believe this is about sort of connecting, all this stuff we're doing here is on the CPU, and what is in our shader program is on the GPU, and this is actually corresponds to here. Now later, when we have more stuff going on, this will kind of become relevant, where we have, if you're passing more data to the shader, for example, texture coordinates, you're going to have more going on here. But for now, it's just vertices. And so we start in location 0, and this is just the way that we do things here. So vec3, and yeah. So OpenGL, even if you're just doing 2D stuff, OpenGL, basically it's a little complicated to explain, but once you understand it, it's simple. Imagine a cube, okay, that is, so you have 0, 0. Let me just bring up the camera, because I'm going to explain stuff. My camera is lagging a bit. Hold on. Gotta reset it, I guess. Okay. So the memory just got flushed through. All right. What was I talking about? Okay, so imagine you have a cube centered at 0, 0, 0. So it's three-dimensional. You have x, y, and z coordinates. So it's a 1 by 1 by 1. So it's kind of the most basic cube you can imagine, right? Again, centered at 0, 0. So it goes, am I doing this right? 1, 0, 1, -1. Yeah, I think I am. 1, 0, 0, 0. Sorry, actually the cube is, it's a 2 by 2 by 2 because it goes from -1 to 1 in all three of those dimensions. I think that's right. I'm going to have to check later. Anyway, so you're imagining this cube, and yeah, this is complicated to understand, but what happens is, imagine, so we're trying to make a 3D world eventually, right? Now some games you don't need 3D, you just do 2D, but eventually in this tutorial I will be getting to 3D stuff. So anyway, but anyway, just if you're only interested in 2D, just bear with me. Try to understand this, how this stuff works, because you need to understand a lot of the same stuff. But you have this 3D world, and what we have to do is take that 3D world and sort of crush it into this 2D space of the screen. So there's several tricks that we're going to do for that, and so some of the tricks involve matrices. One of the reasons we use matrices is that, well, you can have several matrices, and one of the nice things is that the matrices get multiplied together, and then, yeah, it's kind of hard to explain, but let me try to explain it this way. A matrix can be used to sort of reshape reality. That sounds weird. It sounds like the Matrix movie, right? But there's a reason they chose that title, The Matrix, because you can take a 3D space and manipulate it in different ways using matrices. For example, you can scale the world, you can rotate the world, you can translate the world in different places. Okay, so we have translation moving around like this in whatever. All of this is in 3 dimensions, any direction we want. Translation, rotation, and scaling, right? Those are sort of 3 basic transformations that we're going to want to do. And generally, with games, you have a few different matrices. You have, sorry, I'm getting off on a tangent, but we're going to need to understand this stuff later anyway. You're going to have, usually for a game, you have several matrices. So you have a camera matrix, you have an object matrix. Well, you have, yeah, object transform, an object transform. Well, anyway, okay, I'll try to make this simple. Camera, it's MVP. It's model, view, and I forget what the P stands for. You have world, you have the local object, and the camera, usually. And then you have, okay, so the P, I believe, is perspective, because we're going to need a perspective matrix. Sorry, this video is all over the place. What the perspective matrix does is interesting, because I talked about how you can use matrices for those transformations, right? So you can imagine those matrices that I mentioned. You have a scale, translation, and orientation matrix, or rotation. You can, so for each object, they have those matrices, but they just get multiplied together into one matrix, which makes all the computations simpler, because you take these 3 matrices, your position, which is the same as translation, your sort of scaling or your size, and your orientation matrix. You multiply them together and you get the object matrix. So all your objects in your game have these sort of object transforms. A transform, I'm borrowing that word from playing around with Unity. That's how they talk about things in Unity. So it's kind of this, the idea is you have this matrix that defines these various characteristics. So you'll have one of those for your model. You kind of have one for the whole world, which is actually, so instead of thinking of a camera moving around in different places, you kind of think of the camera as being stuck at 0, 0, 0, and the whole world moves around it. So that's your world matrix, and the world gets shifted by, again, translation, scale, rotation. It gets shifted, so you have a world matrix that kind of defines. And sometimes you can zoom in or out the camera just by adjusting the scale matrix on for your world matrix. So you end up with a lot of matrices, right? And then, okay, then the camera kind of has another thing, which is the projection matrix. And that is going to, so you can imagine your camera is fixed in space, the world moves around it, okay? Various objects move around, and then so your camera is looking out, right? But we need, this is the hardest part to explain, but there is a matrix that is called a perspective matrix. And what that is if you imagine a cube, imagine a cube like this, and imagine, okay, the face that is pointed towards you, imagine just scrunching it while you keep the farther face the same size. The face that is facing you, sorry, this is hard to do. You squeeze it, and so it's smaller. And so you end up with this object that's not a cube anymore. I believe it's called a frustrum, but it's got a smaller face over here, and then it kind of goes out like this, right? And so we take this 3D world, okay, and then we apply this matrix that squishes everything. And that is how we make perspective. It's a trick, of course. So that is the perspective matrix. So you apply all these matrices, and then there's another, and we can think of it as the opposite way too. So, and actually, and that might make, eventually that will make more sense later, but imagine now the opposite change or transformation where you start with this frustum, this small cube. Sorry, it's not a cube anymore. It's the shape that I just described, this kind of squished cube that makes a perspective shape. You do the opposite. You take that shape and then expand it on one side out to form a cube. That's actually what we're going to do, what you actually do, okay? And so I hope you're with me still. You do that because we need to fit this perspective thing onto the flat screen. So yeah, I don't know. I know it's really hard to explain. Maybe later I can demonstrate it in a better way, or maybe I'll provide a link to a video that does it better. But all that kind of stuff is using matrices. And so there's one last thing I want to talk about, which is, so we've done our matrices. We've done positioning objects. We've done the world matrix, transformation matrix. We do then the perspective matrix, and then we need to check z values, which just means we're checking our perspective for what is in front and what is behind. Because in this discussion so far, an object that is directly behind another object, I haven't said how we determine which one is in front and which one is in back. And so after we have, by the way, at the end of this perspective transformation, we end up with a cube. The cube I was describing at the beginning, this from -1 to 1 in x, y, and z, that cube, 2 by 2 by 2, we end up with that. And so we need to, then the last thing we do is check z values, which will determine what is in front and what is behind, and then display what is in front. So I know that was a ton of nonsense. It's not really nonsense, but it's a ton of stuff. And I hope to one day make these tutorials better, but this is what I can do at the moment. So, getting back to reality here, I believe I was talking about layouts, vertices. So let me look at the current project, just glancing over it. We don't have anything in here, but yeah, so the stuff that is in the while loop is not set up correctly yet, because we're not doing anything that has to do with drawing anything. We're not drawing the quad. Quad is just a combination of two triangles that forms a quadrilateral, basically a rectangle. So that's why we have two triangles, first triangle, second triangle. And then these are just the functions that it's meant to be sort of abstracted, so you don't have to really worry about these guts of the functions here. So like I said, we need to change the while loop to actually draw something. So on the left here, I'm looking at the larger project. So I'm going to open main.c. I'm going to change this while loop. I'm just going to copy paste and then explain it. I'm actually going to just getting rid of what's in it and then pasting. So we clear the color and we clear a color buffer bit. We decide to use the program shader program that's up here. We bind the vertex array. We're going to need that. So the object part is just like a kind of a wrapper, if you will. And that's useful to, it's useful to think of that because it's not just your vertices, right? It's a little bit more than that. Then we draw the triangle. We draw triangles, and 6 is the number of vertices because we have 2 triangles, which means 6 vertices. We swap buffers and pull events. The order here doesn't really matter. We could put this at the beginning, I think, but at the beginning of the while loop. But anyway, let's try to run it. Yeah, there's a quad. So I'm going to just change a little bit of it. Let's change the position a bit. So a pos.x blah blah blah, because that's what we've named our vector here. Right, okay, to change it, let's actually just change it like this. This is kind of, we're going to undo this later, but actually let's put the top right corner at 0, 0, 0. So these have z values. Of course, since we're doing 2D stuff, it doesn't really matter. But I believe if I put this these z values as greater than 1.0 or less than negative 1.0, it would be out of that cube that I described before. And so I believe that it would not, part of the triangle would disappear. So we'll run. And now, that's not exactly the output that I was expecting. Anyway, we got something going on. In a future one, I'll try to play with it in a way that makes more logical sense. But at least we got something on the screen, triangles on the screen. So what will be the next video? Probably playing around with color and position of the quad. Okay. Thanks for watching. I'm actually going to just change that back because it created a weird kind of bug. Let's see. It needs to say 5. Let me see something. You know why the position is coming out strange is because this is getting multiplied by stuff. So we'll do this in a more logical and intelligent way later. Maybe using matrices? Yeah. Alright, that's it for now. And yeah, thank you for watching. Also, going to commit that. Renders a quad. That's it. Thank you.